So just to give you an idea, we're going to be deriving things like superposition, measurement, the wave function. So let's just jump right into things. Everybody knows about the double slit experiment. You take an electron, you fire it through two slits, and it hits a screen, and it leaves a mark on the screen. But if you do that a lot, you get a pattern, and it doesn't look like the pattern you'd expect. It looks like a wave pattern. And if we try to explain this with electrons being point particles, it just doesn't work. It looks like the probability distribution that we got on the screen was made by a water wave going through the two slits. So let's just conclude that that's exactly what happened. A wave did go through the two slits. The electron is literally a wave. The height of the wave at each location is just the probability of finding the electron there. This perfectly describes how we get the wave pattern on the screen, but let's look at what happens right after the electron hits the screen. Right after it hits the screen, the electron leaves a mark in one location. Remember, the height of the wave at each location was just the probability of finding the electron there. But now the probability of finding the electron is 100% at the one location where the electron left the mark. This means that the wave has to be a big spike at the mark and zero everywhere else. Scientists say that the screen collapsed the wave because that's really what it did. They also say that the screen measured the position of the electron. And since the electron is a wave, it occupies multiple positions at once, or in other words, it's superposed over multiple positions, or it's in a superposition of positions. Before I move on, just so that you know, this whole video is basically just me reading off my note from deriveit.org, and that has a little more detail, and you can leave questions and comments there. So you should totally check that out, link in the description. So what happens if we only have part of the screen? Let's say we only have the right half of the screen, for example. What happens when the wave gets to the screen? Well, obviously the universe needs to decide whether the electron hit the screen or not. If the universe decides the electron didn't hit the screen, the probability that the electron is on the screen is now zero, because we know it's not there, and so the wave height needs to be zero on the right half of the screen. This leaves a really weird looking wave, but this is genuinely what happens. And if the universe did decide that the electron hit the screen, then obviously the electron will leave a mark, and so the wave will be a big spike again wherever the mark was. Each of these happens half the time because half of the wave is hitting the right half of the screen. We can also generalize this to something that's really asymmetrical, and I won't go through all the details, but it's pretty obvious, and the picture looks something like this. That's my 3-minute rundown into how quantum measurement works and why superposition is even a thing in the first place. In the meantime, all of the math is on the deriveit.org note. Thanks so much for watching. I hope this was helpful, and let me know what you thought of it.